accidentally ended my video, so I had to make another one. But anyway, when I cross multiplied and divided, I get 0.3, or not 0.33, but 33, so that would be 33 minutes. So, or 33 seconds, 33 out of 60, right? So it took him 9 minutes and 33 seconds. That is awesome. 9 minutes and 33 seconds to run up 1,576 stairs. Whoa, I can't imagine what his calf muscles look like, or how his calf muscles felt for that matter. All right, now what we're going to do is we're going to compare linear equations and inequalities. So rather than go through this little inquiry here, I'm just going to kind of talk about it real quick. What do you know is the difference between an equation and an inequality? Well, we know that equations have equal signs, inequalities have greater than or less than symbols. So if I think about what that means, an equation has an equal sign. So it's this equals this. If I have x equals 1, there's exactly one solution. But if I say x is greater than 1, that's a whole lot of possibilities for my solution. X could be 2, x could be 3, x could be 4, x could go on and on and on forever. It's anything bigger than 1. So there's a ton of solutions. So thinking about that, when I graph linear equations, we know that the graph is just a straight line, and my solutions are just those points on that line. But when I have a linear inequality, it takes on a new meaning. What we're saying is, again, it could be all of the solutions on this line, or either everything above it or below it. It depends on which way my symbol reads. So and sometimes it could be the points on the line, and sometimes it's not. We call that inclusive. If I'm including all the points on the line, then we talked about that the last time, the closed half plane and the open half plane. If that inequality says greater than or equal to, then that line is going to be solid, and I'm going to shade that and everything above it, or everything on that line is a possible solution and everything above that line. But if I just said it's greater than this, then I'm going to start at that line. I'm going to use a dashed line to show that it's open. I'm not including the points on that line, but everything above it would be a solution. So there's a lot to take into consideration when we're looking at inequalities. There's a whole lot more answer choices. So this kind of breaks it down. X is equal to 3. We only have one solution. X is greater than 3. We have a whole lot more solutions. So I'm going to just go on and we're going to look at a problem rather than me spend a bunch of time going through that. We're going to solve this linear inequality. Looks like it's already been solved for us, so that's nice. It says negative 5.6n plus 12.9 is greater than or equal to negative 71.1. So first we've got to get rid of this positive 12n. Well, we get rid of a positive 12n by subtracting. I keep saying n, 12.9, by subtracting 12.9. Again, property of equality. If I do it to one side, I've got to do it to the other to be fair. So I subtract that negative 12.9 from both sides. Now this is the tricky part. I hope that you remember from Algebra 1, if I divide both sides by a negative, I have to flip the symbol. And I'm going to remind you of why that's true. If I have x, well, let's just use numbers. Let's not use 1 and 2. Okay, obviously my 1 is smaller than 2, right? 2 is greater than 1, or 1 is less than 2. This is a true statement. Now, if I were to divide both sides of this by a negative 1, think about it now. So 1 divided by negative 1 is negative 1. 2 divided by negative 1 is negative 2. Now, which one is my bigger number? The negative 2, or the negative 1? Negative 1 is a bigger number. Think about owing people money. I'd rather owe somebody $1 than owe them 2. Negative 1 is the bigger number. So look what happened to my inequality symbol. When I divided both sides by a negative, I had to flip the symbol to have a true statement. Negative 1 is greater than negative 2. So remember that rule. Don't forget that. I always call it the golden rule of inequalities. When I divide both sides by a negative number, I've got to flip that symbol. So we have the solution set here. When I graph this, n is less than or equal to 15. So we put a solid dot on the 15. We're looking at all the values greater than, no, not greater than, less than or equal to. So showing that it is 15, I include it by a closed dot, and everything less than it goes to the left. And my last problem for the day, writing and solving an inequality. It says nutrition. The recommended daily intake of calcium for teens is 1,300 milligrams. Jake gets 237 milligrams of calcium from a multivitamin that he takes each morning and 302 milligrams from each glass of skim milk that he drinks. How many glasses of skim milk would Jake need to drink to meet the recommendation? So he gets 237 from multivitamin and 302 from each glass of milk. So how many glasses of milk is he going to have to drink to get the 1,300? So let's think about it. We're going to let G equal the amount of glasses of milk that he needs to drink. So for our inequality, he gets the 237 from his, I can't see because my lights went off, but he gets the 237 from his multivitamin. So we're going to write that here if I could see. Get my cell phone here. I have a flashlight. 237, there we go. Plus the 302 per each glass of milk should be at least. So we don't want it to be less than 1,300. We want it to be greater than, but it could also be exactly, because it could be exactly 1,300 or anything more than 1,300 is going to give us, ooh, I look like a ghost, the amount of calcium that he needs. So we're going to check our answers. They are correct. So when we solve it, we subtract that 237 from both sides, then divide both sides by 302, and we get 3.52. So I don't know about you, but I'm not going to sit down and be like, let me measure out 0.52 glasses of milk. To be on the safe side, he's probably going to drink 4 glasses of milk. That way he knows that he got the recommended amount of calcium that he needs. All right, that takes care of this lesson. If you would like to try the exit ticket, I will post it, and you can pause the video and give it a try, and then I will post the answers. And so here it is. Here's the top part. Well, now you can see all of the problems. Pause the video, and here are the answers. There we go. All right, guys, I hope that this was understandable. I'm sorry that I'm a little ADD today. I'm all over the place. Squirrel, keep thinking, getting distracted. But anyway, hopefully you learned something and I wasn't too bizarre. And that finishes up another lesson.